So I'm recording it. I just want to talk here. Nick is here, and he asked just about some general guidance for working in a command shell, and so I'm going to go over that. Okay, Nick. So what I'm going to do is I'm going to share my screen, and now what I have. Uh, okay, I'm going to share. What I'm going to share with you is a. Okay, well this now what you're looking at is you are looking at an SSH session into my Linux box that is right there. It's right here beside me on the desk. Okay, so I have an SSH window open, and I'm sitting here looking at a command shell. Okay, so this thing is basically waiting for me to do something. I can at this point it is a program. It's running a program called Bash, and Bash basically is ready to interpret whatever I type to it. I could give it some. I could give it a script. I could give it some type of instruction. I could tell it to run a program. And if I tell it to run a program, it's going to try and run that program. So an example would be the ls. Now that is that's a command called list, right? So you've used that before, right?
I've seen you use it, yes.
Okay, yes. So if I want to see where I'm at in my with my files, I use ls, and it'll show me what files are there. PWD is another one. That stands for print working directory. That tells me the actual path of the folder. So here's an example. Like this first slash here, it means this first slash right here means the root of the file system, and that always represents the beginning of the file tree. Then the thing after that slash is the folder. So that actually represents a directory called home that's in what's known as the root file system. And then underneath that home folder is my personal user folder. It's called ZeroCell. That's my username, and that's the folder that I use to store my files in. Does that make sense so far?
Yes, sir.
Okay, that's just like if I was in Windows and I was in my desktop and I drilled into another folder and I said, well, what's the path? It would be C:\\, users, and the whatever the folder is. So, okay. So I can use CD to get into a folder, and then CD dot to get back out. So that dot will list all the files in this folder. And you notice I have a dot right here. That dot is a shortcut for the directory that is the parent of this one. And the dot is the shortcut for the directory that is this one. So dot means here. Dot means the folder that encloses this one. So if I want to get back out, I do cd dot. Because it's a directory. And now I'm in the root.
Okay. Okay, that makes sense.
So if I list the files in the root, I have a couple different folders. Home, there's home right there. And I have some other folders. Bin, that's where the executable files live. ITSC is where the configuration files live. So every folder kind of has a purpose here in the system. So with that CD command, I can get in and out. So I'm going to go back into home. Now I'm going to list my files again, and I can see that 0 cell is actually a directory. That's what the D means right there. So one of the first things that the system takes you through is actually the Linux journey. It actually just start to kind of show you some commands. So you'll learn about CD. You'll learn about listing file. Now I'm in my home folder, which is a shortcut for that home folder is the tilde sign. That always means home. Linux had shortcuts before Windows knew what shortcuts were. So one of the things that I wanted you to do, I think, in the logbook is kind of explore. So there's a command called mkdir make directory. So we're going to make it, and so this command actually takes what we would call a parameter. And the parameter is, in this case, the name of the folder that we're going to make, or the directory that we're going to make. So if I were to show the information about the mkdir command, it tells me that it takes, if I want to use it, I got to use some options. And the brackets, the braces mean that these options are optional. And then I have to follow that with the directory. The directory doesn't have any braces, so it's required. So I could use any one of these options, but I don't have to. But I have to give it a directory name. So that's basically the way that command works. So if I wanted to make a directory called folder1, if I just wanted to look at the files and folders, I could do that. And because it's my home folder, I got a lot of hidden directories in here for programs that I've used. But there's my folder1 right there. So I can do cd folder1. I can tab to autocomplete that. And now I don't have any files in there. It's empty. ls command gives me nothing. But if I wanted to create one, I can use the echo command. And now I have a file. Now what I did was I just sent the text hello over to file1. And I use the cat command to concatenate or to type the file out. And so it just spilled it right there on the screen. So in this case, cat is a command and file is the parameter for that command. So another way I could make a file, because what I did here was I just sent whatever I typed in the whatever I typed in the program, I sent it out to that file with the redirection. But what I could do is use the command called touch. I could make file 2. So now if I look at my files, I have 2 files. I have file 1 and file 2. This file command tells me that both of these files are, one of them contains ASCII text, and the second one is empty. So that file command can tell me about whatever file I want to query about.
Okay. Just tells you whatever's in it.
Yeah, it tells me, well, it tries. So sometimes it is not as capable as it could be. So I'll give you an example. What we're going to do is we're going to use cat, and the parameter of cat is going to be the random device, random. So that's a device that generates random digits, and I'm going to send the data over to file 2. So one of the things that you notice about how I'm using the command, I'm actually kind of talking myself through it as I type it out. So each one of these parameters essentially is kind of like a code word, you know, to make that happen. And what will happen? What should happen when I press enter on this is that this device that's just generating random digits will throw whatever it's making into file 2.
Yes.
And it should just stay forever until the disk fills up. But I'm only going to let it run about 2 seconds. Okay. So what I'm going to do here is I'm going to list the files. I'm going to say, okay, I want to see all the files, even the hidden ones. I want to see the details, and I want to see the information in human readable form. That's what the H stands for. So that gives me a little bit of information. Now you notice that you see how long I let that cat run for. It just ran for about a second, right?
Mm-hmm.
See how big that file is?
Yeah.
That's 198 megabytes, right?
Yes, sir.
That's humongous.
I guess that's why you warned us about leaving it on for too long.
Yeah, so let's just watch it. You see that junk in there?
Mm-hmm.
That's all the data that's in that file. And so I was just basically it's binary data that's coming out of that thing. Okay. All right, so let's hit it again. Let's see what it is. File. The file that's a command called file, and file 2 is the parameter, which happens to be the name of that file. So what does it say we have? So that file 1 is ASCII text. File 2 is data. Oh, that just kind of shows you, how the system creates. The reason why it's data is because there's some non-printable characters in that file. So what I'll do here is I'll launch the VI text editor, and I'll use file 2 as my input file I want to open. And you see all that?
Whoa.
That's just random. It's completely well. It's pseudo random data. Not perfectly random data. Uh, only nature can generate perfectly random data. Um, yeah. So what I have here is I have 198 megabytes of just junk. So now what I'm going to do is I'm going to take this file and I'm going to say print it, but I'm going to use this command called pipe. And pipe just says whatever the output of that command on the left side of the pipe, you're going to pass it right into the input on the other side of the pipe, on the right side. So I'm going to pass it through strings. Now what I did here was, this is just another program that takes data and gives me data back. And in this case, it's looking for readable characters that are 4 characters or bigger. So let's see, let me open up the manual for strings. So print the sequence of printable characters in files. For each file given, GNU strings prints printable characters, sequences that are at least 4 characters long, or the number given with options below. So I can use this switch right here to change the size. Now let's just think about this. This is random data. So if I increase the length of the string, do you think that I will end up getting more data out of this or less?
I guess more. I don't know.
So what this is doing is it's printing off anything that is 4 characters or more. So let's just say that I do that, and I'm going to pass it through. I want to see every string that is at least 10 characters or more. Okay. So I'm probably getting less data, but I mean it's still a lot because it's 198 megabytes. And so yeah, now I just doubled the size. So now I went to 20 characters, and I got nothing on output. So that system went through 198 megabytes of data that fast, looking for strings that were 20 characters big, and came up with nothing. There's one. So the idea of the logbook is, the logbook is your opportunity to explore a little bit. Okay.
Yes, sir.
And so, you might say, well, okay, so I just passed this file through strings, and with n is 4, and here's some sample output, and so you might copy some of that and paste it and say, okay, so I just decided to do a little experiment and increase the length of n. And you could give me some output there, show what happens, and might even discuss it, or that's kind of the idea behind the way that works. So this first logbook was to allow you to experiment with the different commands and to copy your output, because the idea was that more than likely you're going to have something that's going to go wrong, and it's not going to be what you expected it to be, and so you have to kind of troubleshoot that and find out what happened. So I wanted to see your troubleshooting steps.
Okay.
You know, maybe you misspelled cat and got command not found. Well, what happened there? So obviously that's an error, you know. Anyway, does that kind of answer your question on the command
Yeah.
prompt?
Yes,
Okay.
sir. It really does. That helped a lot,
Okay.
actually.
Okay. Yeah. And so when you look at these commands, and so here's something else. Like when you're looking at if you go into you want to go into a particular folder, okay, and a lot of the commands are in user bin. So we're just going to look at all the files in there. I think I got disconnected.
Yeah.
Okay. Okay. Now it's back. Okay, now I'm showing my screen again. Okay, so yeah, so all these uh, binary files, or executable files, are in this user bin directory. They're all programs you can run. And every system is going to be different. You know, they may not have all of them. So if you want to look at a subset of them, these are all the ones that start with B. You know, what do these things do? All right. So one of the things that you may want to do in a future logbook is pick some commands and go, okay, well, I want to explore what it is exactly that some of these commands actually do. And maybe I want to figure out how to use them. So that may be, you know, something to get you interested in that. I mean, just the fact that there are, let's see, ls type count. Let me type that in. 3,218 different binary files in my user bin folder. You know, those are all programs that do something with data, or they're applications that are running, or something. Pretty amazing. Like there's Choom. I don't even know what Choom does. Man Choom. Display and adjust object-oriented memory killer. Oh, out of memory killer score. So some of this stuff is programming stuff, you know. You may never use it. This particular thing is a programming tool for debugging. Things that probably aren't installed here, but anyway, I mean that's just some idea, you know, of what you can do. Even looking at a command, you know, like ls, for instance. So a normal ls command is just gives me a completely black and white list of files. But what I have is I have my ls command set to where it shows color. So you see, I got color auto here. So that's where this. Whenever I type ls, what's really happening is my operating system is going, okay, ls -- color equals auto. every single time I type ls, that's one of the things that's happening in the background. So if I looked at ls, I could check out some options. And so you see, here's the color option. So I could do dash dash color equals when, and it says never is an option, right? So if I went and did ls color equals never,
Oh, wait.
I get this black and white listing of files that's pretty boring, you know?
Yes.
So one of the things that that you can do here is just whenever you have a command that you want to run, it's just by using the help or the help option or the menu option, you can get a lot of information about some options you can use on the command and what it does. So what other questions do you have for me that I can help you with? Do you have specific questions?
No, actually, that pretty much covered a lot of what I was confused about.
Okay.
Really.
If you come up with something that you